Okay, Unit 4B review, not as long as 4A. It still has to do with quadratic equations, but not as long. No story problems. There's only 7 problems we're going through. First off, I want you to change that 7 to a 6 because I said so, please. Okay. Solve the equation by completing the square. This is the longest problem. It's the biggest pain in the butt of the group. Okay, at least I think. There's 2 answers, but you're not going to find it by, I don't want you to factor it. I don't want you to use quadratic formula. You can't even use square roots if you wanted to because you have 16x in there. So you're going to complete the square, and you got to know how to line up the equation to start with. You need x second and x terms on this side. You need the constant terms on this side, meaning the number constant means the numbers without the x. So the 6 is there. That should be there. Now we minus the 4, and that's 2. So you have 2x second minus 16x equals 2. Now set up your 3 steps for completing the square and also your table because you know you're going to end up with an h equation where you would use the h. Okay, so I make a parentheses big enough and I will be putting a trinomial in that parentheses. Then we'll be factoring the trinomial which into 2 of the same factor. And since it's 2 of the same, it'll be that factor to the second power. Now you're going to put 2 on this side, and whatever's in front of x second, a 2 goes out there. Now you go up and divide both these by 2. So that's 1x squared minus 8x. And this is a, this is b, and we need to add our own c into it. So c equals b divided by 2 to the second power. Now b is equal to negative 8, but we'll just put 8 because the second power renders the negative pointless to put. 8 divided by 2 is 4, 4 to the second, that's going to be 16. It's just basically half the 8, and then that is 4, 4 times itself is 16. Now you have to add to the other side, not 16. You got to take 16 times 2 because you factored out a 2, and that'd be 32. Okay, so now we have 2, and 2 plus 32 is now 34. Now, factor this. This thing here gets factored. So what's the square root of 16? What times itself 16? It's 4. And they both have to be negative 4s because they have to add to negative 8. If that was plus 8, I'd put positive. Then x. So you got 2, you got 34, and then you got x minus 4 to the second. So x minus 4 is the expression that we're going to replace with h. So up here I go x minus 4, x minus 4. Okay, so we got 2h to the second equals 34. Then we have to divide by 2 and then square root. 34 divided by 2 is 17. Now you find the square root of 17. Remember that could be positive or negative. Well, 17 is not a perfect square, so it's an irrational square root, so we divide into 2 square roots. Okay, 17, you'd start with 16, that's a decimal. Then by 15, nope. Or why 15, no. By 9, nope. 4, nope, so I guess it's just 1 and 17. So the square root of 1 is 1. 1 square root 17. You could just put square root 17 if you wanted to. So I put 1 square root 17, then negative 1 square root 17. Then you got to add the 4 behind it. Okay? You can't add it to anything. So 1 square root 17 plus 4. And then negative 1 square root 17 plus 4. Okay? Okay, now next part's pretty easy. You have a complex number. It's called a complex and another complex number. These are called complex numbers because you have a real number and an imaginary number. Real number, imaginary number. Adding any operation should produce a real number and an imaginary number. You have a plus, so it's blank plus blank I. You could also go blank I plus blank. I don't care. So the real numbers I add 4 and 2, that's 6, and then the imaginary numbers negative 5 plus 10 is 5. Done. Now this one's multiplication. you have a real number, an imaginary number, but you're going to FOIL, that's a 1i. So I take 8 times 8, I take 8 times negative 1i, I take negative 6i times 8, and then negative 6i times negative 1i. So 64, that's a real number. Negative 8i, that's an imaginary number. Negative 48i, that's an imaginary number. And then negative 6 times negative 1 is 6i to the second. Now that turns into a real number, okay? Because I to the second is equal to negative 1. So instead of 6 times I to the second, you have 6 times negative 1, which is negative 6. And that's a real number. So blank plus blank I. So the real numbers, you had 64 and negative 6. 64 plus negative 6 is 58. And the imaginary numbers, negative 8 plus negative 48 is negative 56i. Okay, find the quotient. We have to do these differently. This one's relatively easy because that only has one term, okay? Just the imaginary term is all you see. Here there's two terms because there's a real number along with the imaginary number. Here it's just the imaginary number. So all you need to do is parenthesize it and just multiply every term by I. So 8 times I is 8i. 7i times I is 7i to the second. 2i times I is 2i to the second. Remember, your whole idea is to make the bottom so you don't have an imaginary number, so you actually have a real number. I to the second equals negative 1. So 8i stays the same. 7 times negative 1, 2 times negative 1. That's going to be negative 7 and negative 2. So you have 8i plus negative 7 divided by negative 2. Now you go ahead and divide, okay? Both the imaginary and the real by negative 2. So 8 divided by negative 2 is negative 4i. Remember, I goes on the first one. Put the plus. You need the plus there between them. This plus needs to be dropped. Okay, so that's negative 4i. And then negative 7 divided by negative 2. 3.5. If you want to put 3.5, that's fine. I'm not going to be picky on that. Okay, now the next one, when there's two terms, you have to apply the conjugate rule. That means you multiply by a second fraction. You keep the real number the same. You change the sign on the imaginary because that's one you're trying to get rid of. And then the same, and then up here you copy that. Okay, well, you have to use the FOIL method then on both the top and the bottom. So you take 3 times 9, back to the 3 times negative 2i, negative 4i times 9, and then negative 4i times negative 2i. So I get 27 real number. Negative 6i is an imaginary number. Negative 36i is an imaginary number. This is positive 8, but it's I to the second, and I to the second always equals negative 1. So 8 times negative 1 is negative 8. Now we have a real number. Okay, so the real numbers, you got 27 and negative 8. That's going to make 19. The imaginaries, you add the negative 6 and the negative 36, it's negative 42. So 19 plus negative 42i. Now on the bottom, the i's are going to go away. You're going to take 9 times 9, 9 times negative 2i, positive 2i times 9, and then positive 2i times negative 2i. So you get 81, the real. Negative 18i, that's an imaginary, but this ends up being positive 18i, which is imaginary, so the imaginaries cancel out because I have a negative and positive, and if I add those, it's 0. Then negative 4i to the second. This becomes a real number because it's negative 4 times negative 1, which is 4. Then you add the 81 and the 4, you get 85. Now you drop that plus, please, okay? And the I is the second one, so the I is placed here. So I divide 19 by 85. Don't like that second PRB, so it'd just be 19/85. Then negative 42 divided by 85. I don't like that second PRB. Negative 42/85. I. Okay, there you go. Okay, last two problems. Solve the equation using square roots. This has two answers. Put a square root. Square roots are easy. You have x second, you don't have x. Okay, so you're getting the x second by itself. Plus 3 to 37. I made a mistake. This 2 needs to be a negative 2. Okay, that's my fault. This 2, I want that 2 as a negative. So negative 2 times x to the second equals 40. Then you need to divide by the negative 2. X to the second equals negative 20. Okay. Then you square root, but you have a negative, you're trying to take the square root of a negative, so you make that positive and you poke the I out. Okay. So x could be positive or negative. Now 20 is irrational, it's not a perfect square, so we have to divide. Now if that would be the square root of like 25, I'd put 5 down here, 5i, but it's 20, so I need to divide it into two divide it into two factors, one of which needs to be a perfect square. 16, no. Nope. 4 and 5, okay. So don't keep the square root of 4. That becomes a whole number 2. So it's 2 square root of 5, and then you put the I behind it, okay? So the answer is 2 square root of 5i, negative 2 square root of 5i, okay? Okay, number 7. Solve the equation using the quadratic formula. 3x to the second power minus 5x plus 8 equals 0. It says quadratic formula. This is not complete the square. Quadratic formula, you need 0. Okay, you have it, so you go. That's the song. Opposite of b, plus or minus the square root, b squared minus 4ac, b squared minus 4ac over 2a, over 2a. Okay, so you got 5 for the opposite of b, negative 5, b to the second, 4a is 3, c is 8. Okay. Then a here is going to be 3. So you got your 5, 2 times 3 is going to be 6. So you line that up, and you punch that. Okay, we're good. Okay, sorry. Okay, so then you punch that into your calculator. Not with the square root, though. You're going to do the square root over here. You'll have to simplify it. 4, 3, and 8. Okay. Negative 71. Okay, well, we're going to have to poke the I out. When we poke the I out, you're not allowed to do a decimal. I'm sorry. Okay. So, divide, square root times square root, put that I beside it. Okay. So 71, what's 71 divided by from up there? Well, 64. Nope. 49, nope. 36, nope. 25, nope. 16, nope. 9, nope. Nope. Oh, I guess it's 1 we use. 1 and 71. Square root of 1 is 1. So down here you put 1 square root of 71i. Okay. Now, don't do anything else. Okay. So you go 5 plus 1 square root of 71i over 6. And then 5 minus 1 square root of 71i over 6. You don't leave it, okay? If you're in trig, you might want to look at these outsides and see if you can reduce those down. But 5, 1, and 6, the only common factor they share is 1, which then means it's already in simplest form.